Hello everybody, this is Dr. Nurbat Shah. In today's video I'm going to talk about Runge Kutta method by using calculator and Matlab implementation. Okay, so there are three methods for solution of differential equations based on Runge Kutta. That's the Runge Kutta second order, which is basically the improved Euler method. Then we have RK3 method as well, and we will be talking about RK4, which is obviously used for Runge Kutta fourth order method. Okay, we need to convert the differential equation in the form y dash is equal to f of x y with some initial condition y of x naught is equal to y naught, and we have to solve this differential equation over the interval a to b, keeping in mind that a is equal to x naught. Right, so the steps are, we first discretize this interval by taking a step size h, and as I said, a and x naught, they will be same. X naught will be taken as a, and then we consider the following points. X1 will be taken as x naught plus h, x2 will be taken as x naught plus 2h, and so on. Generally we take xn equals x naught plus nh, where this quantity is the right end of the interval, that is equal to b. Okay, so the formula used for solution of differential equation by using Runge Kutta method, fourth order method, that is yi plus 1, that is yi plus 1 by 6k1 plus 2k2 plus 2k3 plus k4 for I is equal to 0, 1, 2, and so on. When you take I equal to 0, that give you y1, which basically means solution of the differential equation at x is equal to x1. When we take I is equal to 1, that will give you y2, and y2 is basically the value of solution of this differential equation at x equal to x2, and so on. We will be moving up to n minus 1, because yn will be representing solution of the differential equation at x is equal to xn. Now it involves these four constants, k1, k2, k3, and k4. These constants will be determined by using the following expressions. So k1, that is simply h times f of x I yi. K2 is given as h f of xi plus h by 2. We are basically adding half step into x, and half of that k1 into y. So we take h f of xi plus h by 2, yi plus k1 by 2, and k3 is equal to h f of xi plus h by 2, yi plus k2 by 2. Okay, and then we have k4, which is h f of xi plus h yi plus k3. So all these equations together is known as a Runge Kutta method of order 4. Okay, let's do an example by using calculator. I'll be explaining the tricks we used in calculator to do all these steps in one way or in one go. Okay, let's consider a differential equation of the form y dash is equal to y minus x with initial condition y of 0 is equal to 2. We need to find y of 0.1 and y of 0.2, which basically means we need to find solution of this differential equation at x equal to 0.1 and x equal to 0.2. It should be noted that in this case we may take h equal to 0.1, because if you see x naught is 0, so we may take this one as x1 and corresponding y1, and this is x2 and corresponding y2 will be found. To improve the results, we may choose h to be 0.05. In that case, we'll be finding y of 0.05, which is obviously not required in this example, but it will improve the results for y of 0.1. So we'll be finding y 0.05, which will be our y1. We will be finding y of 0.1, which will be our y2, and y2 will be required in this case. Then we will be finding y of 0.15, we will be finding y of 0.2 as well. So if you decrease the value of h, obviously the values will be improved, but it will increase the number of steps. For 0.05, we'll be using we'll be finding y1, y2, y3, y4 to reach to this y of 0.2, and so on. We choose here h to be 0.1. okay, so you see in this case f of xy is y minus x, keeping that in mind. Our initial value of x is 0, whereas y is 2. We assume h to be 0.1. We can take 0.05 as well. Then x1 will be 0.1 corresponding sorry, this is not y1, this is x2. Let me make this correction as well. So this is our x2 basically. This is not y1. We need to find y1 obviously. So let's call this x underscore 2. This is my x2. Okay, okay, so we were doing that, like example is to solve a differential equation. Y dash is equal to y minus x with y of 0 is 2. So I said that it is x1 is 0.1, whereas x2 is 0.2, and we will be finding y1 and y2. Okay, so to find y1, so we need to choose I is equal to 0. So for I equal to 0, we'll be finding k1. So k1 will become h f of x naught y naught. And keeping in mind that our f of x y is y minus x, so we'll be having h, and this will become y naught minus x naught. Now h is 0.1, you see, and y naught is 2, so you can simply put 0.1 and 2 minus 0, that is 0.2. So k1 is 0.2. okay, and then we go for k2, which is h f of x naught plus h by 2 y naught plus k1 by 2. This is h y naught plus k1 by 2 minus x naught minus h by 2, because we will be subtracting this quantity because of the function. It's y minus x. So in this case, our y is y naught plus k1 by 2, and our x is x naught plus h by 2. So we'll be having y naught plus k1 by 2 minus x naught plus h by 2, which become minus x naught minus h by 2. Now putting the values, it's 0.1, we have y naught to be 2, it is 0.2 dividing by 2, that give you 0.1, minus x naught is 0, and h is 0.1 divided by 2 is 0.05. When you simplify this, this will give you 0.05, and so on. And similarly, we could find k3 as well, k4 as well, and then we put all these values in this formula. That's y1 will be y naught plus 1 by 6, k1, k2, k3, k4. Altogether we get 2.2052. Now the question is, how do we find all these values by using calculator? I'm going to explain that. Okay, so first you must remember from my last video that we want to have mode of the calculator be in maths mode, okay, and it must be in radians as well. Okay, so what do? We are basically labeling something, keeping in mind all of them. We are using x, we'll be using y, we would need k1, k2, k3, k4, and I'll be using a variable for h as well. So these are the things I'm going to use in calculator. So I'll be labeling k1 my a, keeping this in mind, K1 will be A, K2 will be B, K3 will be C, K4 will be D, and for X I'll use X, for Y I'll be using what? I'll be using Y. Whereas for H I'm going to use M. Whatever, you could use anything. I'm going to use M for it. And the second thing is I'll taking x naught plus h by 2 here and here. So I may call this x naught plus h by 2 is my simply I could call it f or e or something. Because if I use that as x plus m by 2, what would happen, we may be out of spaces later on when we put all these values. Okay, because it's a long expression. We'll be having y is equal to y plus this expression, and we'll be having k1 expression, k2, k3, k4. So all of them are very long expressions, so that may lead to a shortage of space in the calculator. So you must be very careful to use these notations. You may be using sometime somewhere something else as well, to just replace that by one value and then put the value into it. Okay, so let me define A, B, C, D first. So I'm going for A first. This is my A. So I'll be going for A equals, see, that is my what? A is my K1, keeping in mind. So K1 is H, which I said I'll be using M for it, and then I'll be using the function f of xy, which is y minus x. So I'll simply use bracket and I'll write y minus x. I'll be sorry, it's my fault again. Shift and then my y here, then minus, I'll be using x then. So this is my k1, m into y minus x, because I'm having function is y minus x. Okay, and then we take colon here. Then I'll define b. So my b is equal to again h. So I'll be calling it m multiplied by, now keep in mind I am using what? I am using replacing this x naught plus h by 2 with something else. So I'll be having y plus k1 by 2. This is my y, and then I'll use k plus, use this fraction just to use minimum number of space, amount of space. So that's y plus k1 by 2, and you should remember k1 is a, and this is divided by 2, right? And then I'll take minus, so you see minus, it is x naught minus h by 2, but what do I call it? I may call this something like f or e, whatever you can call it anything. So instead of using that x minus and then a m by 2, I'm using simply e. So I'll be basically saving some space for myself. Okay, and then we have again colon, and then again go for c. So my c equals again this one, and I'll be multiply m with again, and now I'll be taking y. It's y, and let's take y. Then we have plus, again using this fraction. I'll be using now b here because it's k2 by 2, so it's divided by 2. I'm basically using this one, and minus, again you see that it's the same thing, e. So I'll go for minus e. I'll be explaining how do we take the value of e then, right? So this is my e, now closing the bracket again, and then we go for this colon. Now we will define d. So d equals again multiplied by h, which is m, bracket. Now we have x naught plus h, so I'll be simply taking this one, which is y naught plus k, for which I'm using y. So it's y plus C minus, and this is x minus h. So I could simply use x minus m, because our h is what? That is m. Okay, so we all done with k1, k2, k3, k4. Now I'll define what? I'll be defining y here. So again colon, let me use that y equals using y again. It's see, y equals, y means yi plus 1 is equal to the old value. That's the new value, that's the old value. So what I'm using same variable for it, plus, now I'll be taking this 6 in the denominator, so I'll simply use this fraction. I'll take a, so a plus 2 bracket, then I'll use b plus c closing the bracket, and then we have plus d, and in the denominator I would have 6, so it's divided by 6. So we are all done with it. Now you see that I'm having a is my k1 and b is my k2, c is my k3, d is my k4, and this equation will become y is equal to y plus k1 plus 2k2 plus k3 plus k4, and then dividing by 6. So I'll just press this calc now. It will ask for m from me. So for in this case our m is what? That is h, which is taken as 0.1, right? So it's okay, already 0.1 there, so I'll just replace it 0.1. You can have 0.05 as well now, because you're using calculator now. Now y is what? The initial value of y is 2, so I'll just give it 2 equal, and then they are asking for initial value of x, which is 0, so I'll just put 0. Now it will ask for e. Now what would e be? You see, we have called x naught plus h by 2 as e. H is 0.1. Now 0.1 divided by 2 is 0.05, and plus x naught. Now you see x naught was taken as 0, so we'll be using this one as 0.05. When you take x to be 0.1, then you will take this e to be 0.15. So I'll be taking this one as 0.05. This will be my e, which basically means 0 plus, you see that from here you can say 0.05, and next step will be having 0.15 when you go to the next step, and so on, because is for is replace the value of x, so we'll be doing that. And then we press equal, and see we get what? We got a is our k1, so if we want to check the value of k, that is 0.2. You see, we get exactly the same value. And when you press another again equal, so you'll be getting the next value is of k2. So if you check that, it's 0.205. You see, that's the value we have. You press equal again, and then we check it in the decimal points. We have 20525. Exactly the same thing here. Then we press equal to get 0.21053. So 525, or it's okay, it's 53. Now if you press equal, you'll be getting the value of y, which is 2.2052. If you round this up to 4 decimal places, if you go to 5th decimal place, you'll be at 2.20517, and so on. Now can we extend this to the y2? What would I do when I go for the next step? So you see, if I want to find the next value, okay, so that is for I equal to 1, I'll be doing, I'll just pressing again equal. I don't need to do anything else. So pressing this equal, again it asks for m, but m is fixed because we are talking about h equal to 0.1. So I don't need to change this value again. I'll just press equal again to get the value of y. We don't need to change because we'll be using this value 2.20512. Press again. Now it asks about x. For the second step, we take x1, where x1 is now 0.1. So I'll replace this 0.1. okay, and then press equal. Now it's asked about E. You will be taking, I said earlier, when you say my x1 is 0.1, then your E will be 0.15. When x will be 0.2, your E will be 0.25. You will be adding 0.05 to that, the value of x. So you see, in this case I'll be taking 0.15 because my x is 0.1, sorry. When I press equal, it will give me simply k1, which is 0.2105. Press equal again, I'll get 0.21605 for my k2, okay, and then I go for k3, which is 0.2163223. There might be a bit difference because we are considering a small number of decimal places here. And then we have D, which is k4, is 0.22215. And then we press simply equal to find the next value of y, which is 2.4214, correct up to 4 dp. Okay, you can find y3 as well, you can find y4 as well in similar way, but we are asked in this example to find y.1 and y.2, so we need to find this value up to y2. Again, I made a mistake, it should be y2. I don't know why I have written this y1. Okay, this is y2. So our y2 is 2.4214. So yeah, it completely depends on the nature of the function f of x y. If the function is long, so you must be very careful in using calculator, because your calculator may be out of space. So you must be very careful about that. Okay, so that's what we have in RK4 method using calculator tricks. Obviously, this is making a calculation a bit shorter and easy as well if you do all these things correctly. Okay, the next step was how do we implement RK method in Matlab. It's very simple, there is nothing to be worried about it. So you see, I just introduce a function. My output is what I am interested in, y only. If you are interested in k1, k2, k3, k4, you can simply write it k1, k2, k3, k4, but we don't care about that. We only care about the value of y. So I'll be defining the value of x. What are the value of x I want to enter, right, including the initial value as well. This is my initial value of y, and this is my h, how much h you want to select. This is the function of the right hand side of the differential equation, and this is n, how many points you want to do. That is usually the size of x. So you can just input it, or you can define it here that I'm interested in simply size of x. Okay, so you see, I'm taking the first value for y to be y0. That's the initial value, because Matlab accept y1, it doesn't accept y0, y0. So we have to start from y1. The y1 basically means that it's y0 basically, yx0 basically. Okay, now you see we have to go for the loop. That's for I is equal to 1 to n. I'll be finding k1 first. It's a very similar formula. You might have observed that in the slides. It was x underscore I, y underscore j, x I, y j, but Matlab is not accepting that, so simply go for x I and y j. And then we had x I plus h by 2, y I plus k1 by 2. For k3 it was h by 2 plus x I and y I plus k2 by 2. And then we were finding y I plus 2, sorry, I plus 1. That means we'll be finding y2. So y2 is y1 plus 1 by 6, k1 plus 2 times k2 plus k3 plus k4. And that will compute all the values of y and store them in one variable, that will be y. Okay, so it's a very simple and short code. There is nothing to be worried about it. Right, how do we run it? So see, if I take x to be my, I've saw the same example I've done a bit earlier. So I'll take x is equal to my 0, my 0.1, because I'm interested to go up to 0.2. You can go for 0.3 as well, 0.4 as well, and so on. Okay, I'll define the function, so I'm just calling it f, and then I'll use alpha. I use that quite few times, and then my inputs are x, y. So I'll add them as x, y, and then I'll define the function which was y minus x. So if you input that, you see we are having a function x, y dot is y minus x. It will be simply putting this value here directly. Now let me just take this one, copy this one from here, okay, and just simply say I want this quantities are equal, and then we have control V. Now you see we have defined x. I'll just give the value of y naught, which is 2. I'm interested at h equal to 0.1, where f is already defined. I'm okay with n equal to 3, obviously, n equal to 3, because 1 is y1 and then 2. So I'll be interested in 2 only. Okay, and then I simple input this, and you see we are having all the values. That's the initial value. This is my first value, as I've done a bit earlier, and this is our second value, 2.4214. If you remember from here, it's a 2.4214, whereas the previous value was 2.2052, which is exactly the same what we had here. You see, 2.2052 and 2.4214. I hope it's clear to everybody. I would like to see you again some other time, and thank you very much for being with